Okay, thank you for your nice introduction. The It's a great pleasure for me to have a chance to present my study with the title on this screen. And thank you again for the ETAS people supporting this project. As you may imagine, I'm engine guy, still investigating on the engine. And before moving on the slide, I want to emphasize the market trend for the engine development and what we are doing in Hyundai R&D Center. As you can see, for the hybrid is getting popular and popular nowadays. It is a very a significant importance in Hyundai Motor Company, and the ICE engine only still have a big portion in our product portfolio against the new regulations such as Euro 7 and Tier 4. This is also a very important one, and we are still finding some emerging technology such as the last one, the extended range EV. That is some emerging product for the U.S. market and Chinese market. If you compare this market needs to the 1 year ago, for example, there is some big changes. That means the market is changing very fast. And what should we do in Hyundai R&D Center? The requirement for the engineer is that we have to develop with having extreme flexibility to meet the market condition. So let me briefly introduce our ICE XEV roadmap until 2035. We have a different portfolio for the high performance premium car to the new engine with having ultra high efficiency. And actually the engine is still having an important role to contribute finally to the carbon neutral society. This is what we are doing in Hyundai R&D Center. And in this study, I mainly focus on some engine development with the completely new combustion concept with the new component as well as some after treatment system. And I will introduce in details in the following slide. So here is one test vehicle, and it has new type of the engine having an ultra high efficiency combined with the existing motor system. By combining these two things that we call a hybrid system, we can increase the fuel economy with optimized control. And within the engine, there's a new component such as high voltage electrical supercharger. And also, as I said, we applied the so-called lean combustion. And by the combustion itself is lean, we also need some new types of the after treatment system to reduce NOx emission. So I don't want to go further for each technical details because today it's not my main interest in this presentation, but just remember that there's four distinctive features in this hybrid vehicle. And we already finished the preliminary phase with this technology. We already achieved more than 10% of pure benefit, but it is mainly on the chassis dyno. It is tested only in well-known test cycles such as WLTP or FTP. So the question is, if we make some decision to mass produce this technology to the market, can we predict the effectiveness of this new technology when it's actually mass produced? And there's a full subsequent question that has to be answered to make decision. And one is what would be the real pure economy benefit, not the homologation value. So how the real customer can get benefit. And for the new components, such as the electrical supercharger, how the new component will operate in real situation. And as I said, we applied completely new combustion concept and how the new combustion on the road can be active in the situation. And we have to also consider the real driving emission in here NOx on the road. So to answer this question, there's a two approach is in our hand. One is real test and one is virtual test. This is directly comparison performing the same task but with a different methodology. The upper side, there's some real load testing. It is very existing method and very familiar for the test engineer such as me. And let me briefly introduce. We make as much as a prototype vehicle, and we do fleet test in various surrounding, and we get a measurement and analyze. That is very conventional methodology, but as you can imagine, it costs a lot, and it will take quite a long time. For example, 3 or 4 months will be taken. So we decided not going this way. We get some challenges. The same task should be performed in different way, so-called virtual testing. And how we can do it by the support from ETAS, with having the full tool chain, or ETAS software supported us each step to do the same task in virtual methodology. And I will try to explain how we can do it, and what was the result, and what was the result in terms of time also. So let me briefly introduce the overall progress that we were doing in this study. We started from the existing engine model that we have in Hyundai R&D Center, but to go to the cloud system, we have to convert our existing model to the CoSIM platform, and the huge amount of computing has been done in the cloud system to make the a short time for the all needed computing. And also we have tried some automated visualization progress. So let me try to introduce each step. Here is the starting point. I call it step 1, but it is in a Simulink environment, because we have to start with the existing resource. Like the real vehicle, we started from the existing model, but the new feature has to be added. For example, the engine is newly built, and including the electrical supercharger and a new after treatment system model is also added and connected to the existing a hybrid control unit, and then eventually in this study, a certain model has been integrated in this Simulink environment. And in this step, thanks to the ETAS Mocha software, we can optimize the lookup table values, which can represent we can have a good matches to our test measurement. And if you see the green one and gray one, the simulated, the blue one, and it having a good matches after the completing the Mocha optimization. So the engine could be optimized quite well in terms of the fuel economy and NOx behavior before catalyst and after catalyst, and state of charge is well matched. So in numbers, the fuel economy accuracy was within 2% for within 10% for the NOx emission. It is, I think, a sufficient accuracy level for us to go forward in this project. Now in step 3, the same model has moved to the COSIM environment, but to do that, the same Simulink model is converted to some universal format called FMU, and all 13 FMU models connected in the COSIM environment. We also did some similar validation progress to confirm that the all calculation is perfectly same in Simulink environment. The reason why we move to the COSIM is that COSIM can create some cloud the compatible model. So now we are ready to go to the cloud system. So here is some screenshot in an ETAS cloud called Model Simulator. After uploading the cloud model from COSIM, we also have prepared some scenarios. It consists of 126 different speed load gradient profile, and we believe this is some representative European road, and in total it corresponds to the 23k kilometers in distance. So if we run one scenario, it is equivalent that the real test vehicle running 23k kilometers in real European driving load. And we could also add some control strategies with DCM format, and we could try to find out which control strategy would be more beneficial, not in a certification cycle, but on the real European cycle. So if I introduce the computation speed, when we do one scenario having 126 the different profile, we could finish in an hour. That means compared to the common laptop computing, it is huge the amount of benefit in terms of the calculation time. And as I said, this 1 hour cloud computing, we could get this distance range of vehicle measurement equivalently. Now, in this final stage, we move to the ETAS EATB to make some automated visualization as well as the good analysis, because the result from the cloud, the file size is too big, so we cannot have a close look at each measurement manually by the engineer. So we have to make some nice automated progress thanks to the ETAS software. We just added some specific code for our configuration for our lean combustion hybrid system. and we could check the pure economy, electrical supercharger power range, and NOx emission and engine operating mode, etc. in one setup. And let me show you one important screenshot from EATB. If you remember our four distinctive features that if we compare the result for the pure economy first, we have the 11.1% pure economy benefit compared to the current model that is already in the market, and by computing, and we could also check that electrical supercharger power range is quite below than our expectation, and we could also check the Rimban can be active 85% in total engine operation time. And lastly, when we calculate the emission thing, there's a slight increase compared to the existing engine, but it is quite low for against the emission Euro 7, the RDE limit. So I think we are quite safe for the emission. And besides this, we could do some more detailed analysis for the pure economy, and we could the more detailed shot for the best and worst pure economy, why they are doing showing this result, and for the energy analysis also, and NOx and some specific topic R&D generation also, we could prepare all the needed the visualization analysis in each screen. So let me get back to the original question we had. Now we can answer all four questions. For the pure economy, we could get slightly higher benefit than we expected in the certification cycle. And we could also check the new component behavior on the real load. And we could check the Rimban and lean combustion is nicely active, having 85% of total engine operation time. And we are quite confident based on calculation that the NOx emission, and we are quite safe for the RDE regulation. So let me conclude with this slide that applying the virtual test in this study can be used as a very practical solution, and due to the indirect comparison, the real test of performance can be theoretically reduced in 1 hour by the support of the virtual plus cloud system. And for the some calculation for the power split one, we could finish the not having any real test, only relying on the cloud system. We could do some specific calibration test. I wanna finish my presentation with emphasizing my personal opinion for the virtual development. So we have a good engineers in domain area. The Hyundai has many good domain experts, and in this study, the ETAS takes on role for some integration expert, and in other words, the methodology expert. And if we collaborate, we could get very nice answers based on the virtual testing. So the final comment for me, even we were able to get good result from this one use cases, but I want to also emphasize that we cannot go only with virtual. The real testing is also important to support the virtual testing. And this is my final comment for my presentation. And thank you for your attention.